Hello everyone, welcome to Magnetism moving coil galvanometer. Now, before I move on to the principle of a galvanometer, this is made of phosphorus bronze strip. This is the soft iron core. This is the coil around that soft iron core. This is made of hairspring, and these are terminal 1 and terminal 2 connected to the external circuit, which then provide current for the to flow in this coil. And here we have a concave mirror. Now this might look like a weird setup for a galvanometer because when the first galvanometers were being developed, they were not like the modern galvanometers which showed easy needle readings on a small device. No, they had this setup, and here when this coil or this core experience some torque, it would turn, and here it would get off sunlight to the concave mirror, which then would reflect it like this, and hence there would be a reading on the outside which showed how much torque was experienced. And now we move on to the principle. So the principle says that when a current carrying coil is suspended in a magnetic field, it experiences torque or net torque. Now, here we talk about the case in which there is equilibrium between the torque experienced by it, but the magnetic field, and with the restoring torque. Because if you apply some torque from a moving position, it will tend to go back. And here let's talk about the torque experienced by the current first. So we'll write it T D. So this is the torque due to deflection. So we know this is NBIA cos theta. Now here, what is cos theta? Now, due to the shape of this magnet and the current going between the coil, the lines of magnetic field is radial like this. So what radial means is, if this is the radius like this, then the magnetic field will be like this, which will be perpendicular to the radius of the current like this. So what this means is the angle between them will be 0. And here cos theta will be equals to 1. So just remember, this is the key point in the moving coil galvanometer that you will have to remember, that the lines of magnetic field will be radial, which means angle will be 0 and cos 0 will be 1. So this becomes NBIA. Now, what is the restoring torque? Well, if you remember Hooke's laws in class 11, you know that the restoring force is directly proportional to extension produced. The more extension there is, the more restoring force there will be. So similarly, in terms of angular terminologies, it will be that the torque will be directly proportional to angular displacement. The more angular displacement it experiences, the more restoring torque there will be. And eventually the deflecting torque and the restoring torque will be equal. And here this will directly proportional to theta, or tau r will be equals to k theta, and here k is known as the torsional constant, and its value will be tau by theta, which is Newton meter per radian, like that. Now, when these two are equal, tau d equals to tau r, NBIA, I'll write it off here. So tau d equals to tau r, or NBIA equals to k theta, and I'll write current equals to k NBA whole theta. Now here this k and BA are all constants, So I is directly proportional to theta. What this shows is, well, the more current we provide to this surrounding coil, the more, well, deflected the coil will be. The more current we provide, the more the deflection is. More current means more deflection. And this is the proof of that. And we will also talk about current sensitivity and voltage sensitivity. So it's very short. So for current sensitivity, we write it SI. This is equals to the angle per unit current. That means how much is deflected when we apply one unit of current, which is 1 ampere. So how much angle of deflection there is when we provide 1 ampere of current. So from this equation we have, well, this as NBA by K, right? NBA by K. And for second, we have sensitivity of voltage, which is similar to this, which is when we apply one potential difference or one voltage, how much deflection there is, how much angle of deflection there will be. So this is equals to theta by IR using Ohm's law. So SV is equals to theta by I, which is NBA by K, into the resistance. So this is it for moving coil galvanometer. If you learned something new, please like and subscribe. Thank you.